The regC function is one of the most powerful functions in the RCPA3 package, and we use it a lot in the book. In this video, I'm going to focus on the regC function's optional arguments, which implement various regression diagnostic tests and procedures. As you may know, the regC function has one required argument, formula, which is set equal to the regression equation to be estimated. With regC, you have options to specify observation weights, the dataset name, the number of digits you want to see after decimal points, and whether you want to print your results to an HTML file in your working directory. The regC function's optional arguments, named norm.test, ncv.test, linear.test, res.plots, outlier.test, and VIF, implement various regression diagnostic tests and procedures. To learn how to analyze regression residuals with the regC function, let's work through some examples. Create some diagnostic plots of regression residuals with our regC function. I'm going to create the plots, show you what the function can do, not go, and to keep the video short, not go into too much detail about what the plots are showing us or how we would interpret the residual diagnostic plots. I would recommend starting with executing the regC function to do the regression analysis and briefly look at the results. So here I've got a regC call that will give me do a regression analysis with the dependent variable feeling thermometer toward police that will be measured on a 0 to 100 scale as a function of the number of years NES respondents have lived at their address as well as their age, and I've weighted the observations using the weighting variable in the data set. So we can see from the table of results we have a positive relationship between years at address as well as age and feeling thermometer toward police. The effective years at address doesn't appear to be statistically significant in this specification. Anyway, so there's our regression model that we've estimated. To generate the residual diagnostic plots, we select the optional argument called res.plots. By default, it's false. If we want to create the residual plots with res.plots, we set the value of res.plots equal to true, using the capital T for true. And when we run this, we will get in the console the same tables, should get the same tables of regression results. There we go, in the additional model information. And then when we hit return to see the plot, we should get a 2x2 plot, diagnostic plot of the regression residuals from this multiple regression analysis. There we are. Our plot window shows the 2x2 plot. I'm going to export it to the clipboard in order to get a closer look at it. Make the plot a little bit wider or larger for us to see. Okay, so we've got 4 residual diagnostic plots: the residuals versus fitted values, QQ plot, scale versus location, as well as residuals versus leverage to help us look for influential observation and potential outliers. So this is kind of a standard set of residual diagnostic plots. There are more residual diagnostic plots than this and variants on these themes, but these are 4 that are automated and built in and easily to obtain using the regC function using that res.plots argument. Let me show you how to implement some diagnostic tests of regression residuals using arguments to our regC function. So again, to get started with this, I would start by just simply estimating the regression model and examining the tables of results, the table of the coefficients, the table describing regression residuals, and maybe even the additional model information. So here I'm looking at a model of feeling thermometer toward police as a function of a couple independent variables: years at address years, that's the years at address, and the age of NES respondents. One of the residual diagnostic tests is called using the norm.test argument, and this is a statistical test to test the assumption that the regression residuals follow a normal distribution, which would be characteristic of random noise. So to test this assumption, that regression residuals follow a normal distribution, we add the optional argument norm.test and set the value, assign the value of that argument equal to true. Now run this and we'll take a look at the results. So it should start with the results that we're familiar with, the coefficient, regression table, additional model information, and just give us a new output, the test of normality of residuals. And this test applies the Jarque-Bera test to test the null hypothesis that residuals follow a normal distribution. Applying that test, we get a test statistic of 592.572, which has a p-value that rounds to 0.000, so a very low p-value. So we reject this null hypothesis. These residuals do not appear to follow a normal distribution, which would challenge the assumption that the regression residuals are normally distributed. Another built-in statistical test tests whether the regression residuals have constant variance. To test the assumption of constant variance, we would select this ncv.test for the non-constant variance test and set the value of the ncv.test argument equal to true. It will look similar to the output I just generated to test normality. We get the same table of coefficients, table with regression residuals, additional model information, but here comes the non-constant error variance test. Using the Brouch-Pagan test, it tests the null hypothesis that residuals have constant variance. According to these results, the test statistic, the BP test statistic, is 359.06. That's compared to a chi-square distribution with 2 degrees of freedom. And the p-value of that test statistic is very small. It is far less than 0.05 or even 0.01. So we would reject the assumption reject the null hypothesis and the assumption that the regression residuals have constant variance. These regression residuals appear to have non-constant variance. So statisticians have developed a variety of methods of post-estimation analysis to help us examine regression residuals and regression analysis more generally to see if we've modeled variation in the dependent variable appropriately. And we've built in a number of these other types of post-estimation analysis into our regC function, and we would use them pretty much the same way that we've generated the residual plots or done diagnostic tests. Let me show you what's available. So you'd really want to begin by estimating a regression model. We've done this already a couple times in the video, running this regC function to analyze feeling thermometer toward police as a function of NES address years as well as age of NES respondents. If we wanted to do some additional post-estimation analysis, we could, sure, I'll do ANOVA, as well as we've done the norm test, ncv.test. We'll do the linear test. We have a reset test, outlier test, we can calculate the variance inflation factors, the VIF. We've done the plots. I think that covers it. So quite a few. ANOVA will test whether our predictors in total explain a significant amount of variation in the dependent variable. Should be pretty obvious that they do, given that one of them is statistically significant, but I will run that anyway. Linearity tests test whether the model is appropriately linear, meaning there's a linear relationship between the predictors and the outcome. It performs a reset test, Ramsey's reset test, to see where the model is correctly specified, or the independent variables in the model are correctly specified, as well as an outlier test to determine if there are significant influential observations driving the results, and will compute the variance inflation factors to estimate the amount of multiclinearity in the model. So let's give this whole thing a run and then look at the results as they come through. Just starts with our standard table of coefficients, table of regression residuals, additional model information. Then we have a ANOVA table to assess overall explanatory power. The outlier test comes up next to identify some of the observations by number that have a high amount of influence on the regression results, possibly an unusual or excessive amount of influence on the results. Gives us the variance inflation factors, which is the correlation between the predictors. We have a model specification test that tests the null hypothesis that the regression model is correctly specified. It appears to do rather poorly on that measure. It tests the linearity of the relationship, and that null hypothesis appears to hold up. I don't want to go into too much detail into the weeds of the specifics of each test, how these different test statistics are computed, but if you do want to use any or all of them, I want to show you that those things are available with the regC function, simply using optional arguments and setting equal to true any test or additional post-estimation analysis that you wish to perform.